Dear students, in the previous episode, we have discussed on the horizontal and vertical distribution of temperature. This episode focuses on the vertical and horizontal distribution of pressure and wind systems. The present episode is consisting of the following modules: air pressure, pressure gradient, vertical structure of cyclones and anticyclones, distribution of pressure pattern, the planetary, periodic and local winds. The pressure and winds are invisible elements which influences other weather elements in a significant way. Variation in pressure from place to place are responsible for the movement of winds, which serves as a means of transporting heat and moisture from one region to another. They also bring about changes in day-to-day weather conditions. Besides, air pressure is all the more important in weather forecasting. Regional variation in pressure is produced by temperature. According to Trivarta, they are crucial to all life form as it controls temperature and precipitation. Like any other material object, air has weight. The mass of column of air above a given point determines the atmospheric pressure at that point. Air has a mixture of several gases. The behavior of air pressure is depending on the behavior of gases. The gas is kept in a closed container, the motion is restricted. The gas molecules always tend to hit the wall. Similarly, land sea surface below and above by the force of gravity does not allow to escape. The amount of pressure exerted by air at a particular point is determined by two factors: temperature and density. If there is a change in temperature, there will be a corresponding change in the pressure also. The following equation, called the gas law, describes the relationship between pressure, temperature and density. Pressure is equal to density into temperature into constant. So, according to the gas law, an increase in either in density or temperature will cause an increase in pressure, provided the other variables like temperature and density remains constant. The atmospheric pressure at sea level will be 1034 grams per square centimeters. This amount of pressure is exerted by the atmosphere at sea level on all animals and objects. Man does not feel the weight of the atmosphere because the air inside him exerts an equal amount of outward pressure, balancing the inward pressure of atmosphere. But sometimes there will be a physiological disturbances when one goes to the higher altitude. Measurement of air pressure. The atmospheric pressure is measured most accurately with the help of mercurial barometer. Evangelia Torricelli, a student of Galileo, developed the barometer. The standard sea level pressure is given as 1013 millibar at a temperature of 15 degrees Celsius and at a latitude of 45 degrees. This pressure is equivalent to 29.92 inches or 760 millimeters. The milligram is a force equal to 1000 dynes per square centimeter, and a dyne is a unit of force approximate weight of a milligram. Pressure recording instruments. Besides mercurial barometer, there are other types of pressure recording instruments such as aneroid barometer, altimeter, microbarometer, which is very sensitive. Standard pressure at sea level is about 1013.25 millibars. Pressure changes from day to day and time to time. In 1893, July 14th, Siberia was recorded the highest pressure, which was about 1075.2 millibars. The lowest of 877 millibar was recorded at Mariana Islands. Pressure gradient. The decrease of pressure between 2 points along a line perpendicular to the isobars divided by the distance between the points is called the pressure gradient. In other words, the pressure gradient is the rate of change of pressure per unit horizontal distance. In fact, it is the direction in which the change is most rapid. The rate and direction of change in air pressure is also known as barometric slope. So, it is expressed in millibars per 100 kilometers or per degree of latitude. A decrease of 34 millibar in a horizontal distance of 24 kilometers or a fall of 10 millibar in 160 kilometers signifies a steep pressure gradient. Close isobars represent steep pressure gradient and vice versa. Low pressure systems, cyclones. When the isobars are circular or elliptical in shape and the pressure is lowest at the center, such a pressure system is called low or cyclones. A line of low pressure is called trough. Lowest pressure at the center, the wind from outside converges towards it. According to Farrell's law, the wind in the northern hemisphere are deflected towards right. So, it is anti-clockwise in the northern hemisphere. On the contrary, it is clock in the southern hemisphere. High pressure systems, anticyclone. In this system, the high pressure is at the center surrounded by low pressure. Centers of high pressure are called high or anticyclones. Therefore, in a high, the wind blows spiraling towards the outer margin. In an anticyclone, the direction of flow is clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. When the isobars are elliptical rather than circular, the system is called a ridge or a wedge with high pressure. Like cyclones, the anticyclones are also differ from one another in respect of their size, shape and character. Anticyclones are larger than cyclones. The isobars usually symmetrical and almost circular. Vertical structure of cyclones and anticyclones. Vertical distribution of cyclone or anticyclone depends on the temperature within it. Cyclones and anticyclones are classified as follows: cold core cyclones, warm core cyclones, cold core anticyclones and warm core anticyclones. The pressure and temperature distribution systems help the meteorologist in weather forecasting. The following figures represent the cross section of a cyclone and anticyclone and their structures. And now let us see the cold core cyclones. Cold core cyclones. In this type of cyclone, the temperature is lowest at the center and increases towards the outer margin. Air registered rapid changes upwards with increasing elevation. The barometric slope becomes steeper. They gradually form in the upper layer. Icelandic, Aleutian, low are the typical examples of cold core cyclones. Warm core cyclones. Temperature is highest at the center and decreases towards the outer margins at the lower level. At the lower level, the temperature is low and increases at the outer margins. Temperature increases with the altitude, low turns into high but decreases at the outer margins. It originates at the desert regions. California, Arizona are the best examples of warm core cyclones. Cold core anticyclones. Cold core anticyclones have the low at the center, and up to certain height the temperature increases, and at the top there exists the low temperature. But at the lower level the temperature is high at the center, decreases towards the outer margins. At the top the temperature will be low at the center and increases towards the outer margins. They originate on the Arctic and Antarctic regions in winter. When they move towards the lower latitudes, they become warm core anticyclones. Warm core anticyclones. Highest temperature is observed at the center. Temperature gradually decreases from the center towards the outer margins. Vertical temperature increases with altitude. Anticyclones of tropical regions generally of this type. Eastern United States, South California during summer are the good examples. Horizontal distribution of pressure. Horizontal distribution of pressure is shown by means of isobars. Isobars are lines drawn through points of equal pressure. Factors which contribute the distribution of temperature governs the distribution of pressure as well. There is a close relationship between pressure and temperature. Since there is a great variation in the amount of insolation received at the different places, there is a corresponding variation in the temperature also. Distribution of pressure pattern. Air rising near the equator moves towards the poles in the upper atmosphere turned aside. The result is that not all the air rising from equator goes to the poles. They settle down in subtropical regions. The subsiding air currents create subtropical high pressure between 25 and 35 degree north and south latitudes. There are two factors to be considered. Rising air currents move away from the equatorial region. The release latent heat keeps them warm. But radiational cooling results in their increased density in the upper atmosphere. Coriolis force gets stronger. The poleward winds are deflected nearly west to east near 25 degree north and south latitudes. Because subsiding air current are relatively drier and relative humidity of the descending air is further reduced by the effect of adiabatic heating, that is why all the deserts of the world are situated in the subtropical high belts. Poleward of the subtropical high pressure belts in both the hemisphere are large, and when they move towards 50 to 65 degree latitude, they become subtropical low pressure belts. This region where cold polar winds and warmer west winds clash called polar front. There are 7 alternating low and high pressure belts. Equatorial low pressure belt, subtropical high in the northern hemisphere, subtropical high of the southern hemisphere, subpolar low of the northern hemisphere, subpolar low in the southern hemisphere, polar high of the northern hemisphere, polar high of the southern hemisphere. Equatorial low pressure belt. This belt lies between 5 degree north and 5 degree south latitude. The average pressure in this belt is less than 1013 millibar. Since the maximum insolation is available in the equatorial region, the intensity of heating is more at the lower layers. The heated air expands, becomes lighter and rises upward. These convectional currents are set up in the atmosphere throughout the year. In the equatorial low pressure belt, the air is warmer and moist. This is the zone of convergence. The wind are lighter and variable and calm. That's why it is called doldrums. During July, the low pressure belt extends up to 20° north latitude. In January, it migrates to the south of the equator. The temperature is high and the pressure is always low. It is thermally produced. The pressure is more uniform than other parts. Subtropical high. The areas of subtropical high pressure are located between 25 to 35° north and south latitude. These high pressure cells are the centers of action. There are no prevailing winds, light and variable. These belts are invaded by extratropical or tropical disturbances. All the deserts are located in this region. These high pressure belts are also called as horse latitudes. Subpolar low. Subpolar low belts are located between 60 to 70° north and south latitudes. Vast expanse of ocean in the southern hemisphere. Vast expanse of the land in the northern hemisphere, which are cold and dry. Pressures over these land masses are increased. During winter, there is a great contrast between temperature of the oceans and continents. In summer, the temperature contrast between the continents and oceans is much reduced. Polar high. Pressures at the poles are constantly high throughout the year. In northern hemisphere, the high pressure areas is not centered at the pole, but near the Greenland and Canada. In the southern hemisphere, Antarctica is the high pressure belt. Thermal factors are more important than dynamic factors. Seasonal variation in the pressure pattern in January. Seasonal variation in the general pattern of surface pressure are represented in the following figure. Figure number 1 represents the pressure distribution in general. Because of the apparent movement of the sun towards the Tropic of Capricorn, the equatorial low pressure is displaced to the south of the equator. January being one of the summer months in the southern hemisphere, the continents of Australia, Africa, South America are relatively warmer and there exist low pressure belts. The subtropical belt of the high pressure in the southern hemisphere is located well to the north. The high pressure exists over North America and Eurasia. Siberia becomes the coldest regions on the earth with highest pressure. During summer, the subtropical belt lies at 30 to 40° south over Pacific, Atlantic and Indian Oceans. There are two low pressure cells found over North Atlantic and North Pacific Oceans. There are Icelandic low and Aleutian low respectively. Distribution pattern of pressure in January. This is the period of summer in the northern hemisphere. Because of the apparent movement of the sun towards the Tropic of Cancer, all pressure belts shift towards the north. Therefore, the equatorial trough of the low pressure also is located well to the north of equator, especially over the warm land masses of the northern hemisphere. The heat lows are conspicuous over the southwest of United States, India, Asia Minor and North Africa. In northern hemisphere, the well-developed high pressure cells found over the North Atlantic, North Pacific Oceans. There is a high pressure cells established over the continent of Australia. But in the northern hemisphere, the subpolar and equatorial low pressure belts merge over the continents. However, the subpolar low pressure belts persist over the oceans. planetary, periodic and local winds. The movement of wind is governed by the uneven distribution of pressure over the globe. In this part of the episode, it is essential to understand the various types of winds which serve as a means of transporting heat, moisture and other properties from one place to the other. What is a wind? The horizontal movement of air along the Earth's surface is called a wind. The vertical movement of air is known as an air current. Winds and air currents together comprise a system of circulation in the atmosphere. The movement and speed of wind are affected by three main factors: pressure gradient and rotation of the earth. Types of wind. On the earth's surface, certain wind blow constantly in a particular direction throughout the year. These are known as prevailing winds. They are also called the permanent or the planetary winds. Certain winds blow in one direction in one season and in the opposite direction in another. They are known as periodic winds. Then there are local winds in different parts of the world. Planetary or permanent winds. The planetary wind systems of the world accompanies the presence of the high and low pressure belts. We know that winds tend to blow from high pressure centers to the low pressure centers. The effect of the Earth's rotation, that is Coriolis force, tend to deflect the direction of these winds. The deflection in the direction of these winds takes place according to Farrell's law. Two sets of surface winds, the trade winds and westerlies, are the main planetary winds of the world. The trade winds. The north and south of the equatorial belt of calm are the trade winds converging roughly the zone lying between 5 degrees and 30 degree north and south latitudes. In other words, they cover almost the entire areas between 30 degree north and 30 degrees south latitudes on both sides of the equator. The trade winds are a result of a pressure gradient from the subtropical belt of high pressure to the equatorial belt of low pressure. In the northern hemisphere, the wind moving equatorward is deflected by the Earth's rotation to the flow southward. Thus, the prevailing wind there is from the northeast and it has been named as the northeast trade winds. In the southern hemisphere, deflection of the wind is towards the left. This causes the southeast trade winds. When they cross the open oceans, they pick up lot of moisture. They bring heavy rainfall to the eastern coast of continents lying within the tropics because they blow onshore. On the western coast of continents, these offshore trade winds do not bring any rainfall. As such, the western areas within the tropics suffer from aridity. The great deserts of Sahara, Kalahari, Atacama and great Australian deserts all lie on the western margins of the continents lying within the tropical latitudes. Polar winds. The winds blowing in the Arctic and Antarctic latitudes are known as polar winds. They blow from the polar high pressure centers towards the subpolar low pressure belts. In the northern hemisphere, they blow from the northeast and are called the northeast polar winds. And in the southern hemisphere, they blow from the southeast and are called southeast polar winds. As these winds blow from ice-capped land masses, they are extremely cold. They are more regular in the southern hemisphere than in the northern hemisphere. Periodic winds. Land and sea breezes and monsoon winds are winds of periodic type. Both are caused by unequal heating of land and sea. Land and sea breezes occur daily, whereas the occurrence of monsoon wind is seasonal. Monsoon. Monsoon winds are seasonal winds. For 6 months, they blow from land to sea and from other 6 months from sea to land. Thus, they may be regarded as land and sea breezes on a large scale in which the period is a year instead of a day. The word monsoon has been derived from the Arabic word mosem, which means season. These seasonal winds greatly disturb the system of the Earth's permanent winds. Local winds. Local winds are the result of a variety of causes. The mountain and valley winds follow a daily alteration of direction in a manner like the land and sea breezes. During the day, when slopes are intensely heated by the sun, the air moves from the valley upward over rising mountain slopes towards the summits. This is known as valley wind. It decreases the cold of the air on higher summits. At night, when the same slopes have been cooled by radiation from ground to the air moves valleywards down the ground slopes and reduces the temperature of the valleys. Conclusion. Perhaps the most important property of the atmosphere is that pressure always decreases with height. But it does not decrease with the same rate. It varies from place to place and time to time. The amount of pressure exerted by air is determined by the temperature and density. When the pressure is lowest at the center, wind from outside converges towards it. It is called cyclones. Similarly, when there is a high pressure at the center surrounded by low pressure areas, the wind blow towards the outer margins. It is called anticyclones. There is a vertical variation in the distribution of temperature amongst these cyclones. There is a latitudinal variation in pressure also. The pressure at the poles is constantly high, whereas in the equatorial regions there exists a low pressure belt. The horizontal movement of air is called the wind. The movement and the speed of the wind are affected by pressure gradient and temperature variations. Wind has been considered as an essential part of the thermodynamic modification of the atmosphere, which serves as a means of transporting heat, moisture and evaporation to the other areas. In the next episode, we will be discussing about the air masses and fronts.